Hello everyone. So today we talk about some properties of ratio and proportion. Okay. So in this session we talk about some important properties like componendo, dividendo, alternando. Okay. This kind of thing, and also we talk about the how the constant term related with this ratio, and it's also used in proving the proportion or that kind of thing. So without wasting time, let's get started. Let's hear that first important properties of the ratio proportion is internendo property. Okay, so here we what happened here, you can see that if a is to b proportion to a, c is to d, then b is to a proportion to d is to c. Okay, that means whenever you talk about a divided by b equal to b divided by c, okay, then we can also talk about that b divided by a equal to d divided by c. Okay, this is not b divided by c. Okay, this is actually uh, c divided by d. Okay, if this happen, this can imply b by a equal to d by c. You can see that if you taking the inverse of both term, then you will easily define this. Okay, here that is the proof here. Now alternando property says that a is to b proportion to c is to d, then a is to c proportion to b is to d. Okay, that means a divided by b equal to c divided by d. If this happen, okay, then we have to conclude that what a divided by c equal to b divided by d. Okay, this can be easily defined if the c is come if the c is come here and b is come this side, then it will be happen by default. Okay, so this is nothing but the nothing in the proof, just you just remember have to the properties. Okay, so another thing that is here, that componendo property. Okay, so componendo property tells us that a is to b equal proportion to c is to d, then a plus b um, is to b is proportion to c plus d is to d. Okay, so componendo property says that if a by b equal to c by d, if this happen, okay, then we need to conclude that plus b divided by b equal to c plus d divided by d. This is the componendo property. Okay, so for proving this, what we need to do here from this, if you add plus 1 both sides, then you will definitely get the proof, that is a plus b plus 1 equal to c plus d plus 1. If you doing that, then you will definitely reach to this step. Okay, so this is quite simple proof here. Now another thing, that similar property, that is dividendo property. So dividendo property is what, then same condition is here, that is a by b equal to c by d. Okay, you can see here a by b equal to c by d, then you have to prove that a minus b by a minus b is to b is proportional to c minus d is to d. That means a minus b divided by b equal to c minus um, d divided by d. Okay, you need to prove that. So for doing that, what we need to do here, that is we just have to subtract minus 1, subtract 1 from both sides, c by d minus 1, then you will definitely reach to this section. Okay, so in this way you can talk about component and dividend property. This component and dividend property uses together. Okay, sometime you have to use the component and dividend property together. Okay, so just remember these properties. This is quite important properties, component and dividend properties, and this use is in various ways. Okay, so another property, that is convertendo property. Okay, now convertendo properties says that a divided by b equal to c divided by d. Okay, if this happen, then a divided by a minus b equal to c divided by c minus d. Okay, so for doing that, what we need to do here, you have to prove this. Okay, yeah, you can see that. Now for doing that, what we need to do here, that is we just need to write same thing, that like dividend property, that is a by b minus 1 equal to c by d minus 1. Okay, whenever you do that, then you will definitely reach that a minus b divided by b equal to c minus d divided by d. Okay, so this is actually the dividend property that we use here, and whenever you taking the reciprocal of these two, then you will reach to this portion, because if you take the reciprocals, that is b by a minus b and equal to d by c minus d. Okay, so in this way you can reach to this convertendo property, that is just we convert the dividend property in a similar in a different manner. Okay, so this is nothing but so if you reach this section, you will be definitely prove that a is to a minus b equal to a is proportion to c is to c minus d. Okay, so this is the thing you need to know here. Okay, so another thing, that is component and dividend property. So I previously said that sometime you need to use the component and dividend property together. Okay, that is why here, that is a is to b equal to is proportional to c is to d, then a plus b is to c, a minus b is proportional to c plus d is to c minus d. Okay, so here our consideration is a plus a is to b is proportional to c is to d. That means we will definitely write that a by b equal to c by d here. Okay, this implies again we just do the same thing that is doing in the componendo, and reach to this portion, a plus b divided by 2 equal to c plus d divided by d. And if you use the dividend property, then you will reach this portion. Okay, this is the componendo property, this is the dividend property. Okay, so this is our componendo and this is our dividend property. Okay, so now what we need to do here, that is we have these two thing. Okay, and now we just divide the corresponding sides. Okay, just this by this and this by this, so we will reach to the reach to our result. So let's see how it's work, that a plus b divided by d and c plus b and a minus b divided by d, c minus d divided by d. So whenever you're dividing that, this will look like this, and you can see that bb is cancelled out and dd is cancelled out here, and so we'll reach a plus b divided by a minus b and c plus d divided by c minus d. Okay, so and we get this result here. So you need to know this thing very carefully, because this uses in various way in the in when you deal with the problem with proportion. Okay, so this property is frequently used in simplification also. Okay, this component and dividend property. So another thing, that is equivalent ratio property. Okay, this is quite important property of the proportion, that is a is to b is in proportion to c is to d, then a plus minus c is proportion is to b plus minus d is also proportion to a plus a is to b. Okay, so this is the thing, and also for the a and c. So here is the proof, that is a is to b equal to c is to d. If you take the a by b equal to c by d, this is a by b equal to c by d. Okay, and this is equal to k. If we taking the k here, that is constant. Okay, k is here, that is constant. So whenever you take this k, you can see that a conclude that a equal to bk and c equal to dk here, that is here. And now if we put the value of a and c, then we will definitely put arise in the constant term. Okay, so a divided by b, a minus b, and b is equal to c divided by c minus d. Sorry, a by b equal to c by d here. Okay, so you can easily conclude this, and you have to take care of the plus minus sign, that is whenever this is plus, this is also plus, whenever this is minus, this is also minus, and we'll reach this algebraic properties here. If you remember this property, that will fine. If you not remember this property, you need to use this kind of operation, and you will definitely reach to the following result. Or also you can remember these properties. Okay, I don't think that will be quite important to remember, but if you have to do that, it will be better to understand. Okay, so that's all for today. We'll see you in the next session.